Okay, everyone, so today we're going to be looking at lesson 44. We're going to be talking a little bit more about the trig functions that we learned in lesson 43. I'm going to do a quick little review just to kind of jog your memories for what we did learn in lesson 43. We talked about these trigonometric functions known as sine, cosine, and tangent. And by the way, we didn't really discuss this the other day, but trigonometry actually simply means triangle measurement. So when you're dealing with trig, you're talking about a triangle. And more specifically, with sine, cosine, and tangent, we're talking about right triangles. We learned that we could have any size triangle if it had the same angle measurements. Then we could use the sine and cosine and tangent respectively would end up being the same measurement. So let's talk about how we remembered how to use our sine, cosine, and tangent. Okay, so sorry, I was just checking. It looked like I hit the off button. I wanted to make sure it was still rolling. We're good. Okay, so remember that sine, cosine, and tangent are simply ratios, and we talked about that. Ratios that are set up for each one of these trig functions. So if we have sine or cosine, this is how we learn that we abbreviate those. We use the side lengths of a right triangle, and it's all centered around an angle's measurement, okay? So we find the angle that we're looking for, and we find that angle's measurement. We call it like sine. In fact, the ones that we talked about the other day all had a 37-degree angle in it. If you remember, I'll just quickly sketch that right here. We had 3 similar triangles, and 37 degrees was right there in that corner angle, and we found sine 37 degrees, and we found cosine 37 and tan 37. But for all 3 of those triangles, the measurements ended up the same. Okay, so let's talk about how we know how to write the ratio. So for sine has a very special way of writing the ratio. So does cosine and tan. And we learned this special mnemonic called SOHCAHTOA. And that helps us to know how the ratio is going to be written for each one of these trig functions. So for sine, we have sine is the S, and then opposite over the hypotenuse. So the sine is always the opposite side over the hypotenuse. For cosine, it's ca, and there's our C for cosine, and we have the adjacent side over the hypotenuse. So for cosine, we would take the side length off of the adjacent side from the angle that we're talking about and put it over the hypotenuse. And for tan, T is for tangent, opposite over adjacent. So there's the 3 different trig functions and their ratios, and that's how you find them. Okay, so we're going to further this now. Excuse me. We're going to further this now in today's lesson by looking at an example together. And actually, I think I'm going to do one right here first. I'd like you to watch one first before we actually start trying to take notes. If you watch me through this, then we'll go ahead and we'll build one in your notes so that you'll always have it. But let's say we have this triangle, and it looks like this. It's a right triangle. Let's sketch it on here. There's my right angle in the corner. We have a side that we don't know is Y. We don't know the hypotenuse measurement. We have B as an angle and 24 degrees here. And of course, we have one more side that gives us a measurement of 9.5. Well, let's say we have to find B, Y, and H on this problem. Well, B is kind of easy to find, isn't it? The measure of B. So this is going to be the first thing I would do because that's the easiest one. So to find B, we know that the sum of the measures of the angles in any triangle is 180 degrees. So I know I have a right angle, which is 90 degrees, and I have a 24-degree angle. I can add those together and then subtract it from 180, and I would end up with 66 degrees. So the measure of angle B is equal to 66 degrees in this case. Easy peasy. All right, let's look at another thing we have to find. Now let's look for Y. What is side Y's measurement? Well, I can use a trig function to figure this out, but the important part of this is going to be, okay, I know 2 angles, but I'm going to go ahead and kind of focus on this one over here. We're going to use 24. That is the one that is given, and we'll just kind of focus on that one. So remember, our trig functions are ratios. of different combinations of the sides on the triangle. So we have to decide, well, which one would be most beneficial to solving for y? Well, obviously, we're going to want to have that opposite side in our ratio because I'm trying to solve for the opposite side of y, right? So we know we need an opposite side. So let's think about this. So we have katoa. Which one has opposite sides in it? This one does not, does it? So it's going to be one of these two. So let's think about that. So if I did the sine, then I would have my opposite side would be y, and the hypotenuse is h. Well, I don't have a figure. I don't have a measurement for h, so this one isn't going to work out either. So it looks like we're going to have to go with tan. So let's write down here tan. We're going to take the angles measurement that I've highlighted in yellow, tan 24. Let's set up what the ratio is. So it's TOA, right? TOA, which is opposite over adjacent side. So let's plug those in. So the opposite side is y, and the adjacent side is 9.5. Okay? So we chose to use tan because we have enough measurements that we can use tangent to solve for our missing side y. So here's what we're going to have. Tan 24, I'm going to go ahead and remove the opposite over adjacent words there. We'll rewrite this as y over 9.5. This is what we're trying to solve for. So, solving for y, right now, y is, let me look here for a really quick, see what I did here. Make sure, I want to check something. Tan 24.45. Y. Okay, I'm good. Alrighty, so what we have to do here is figure out what tan 24 is. So in your calculator, we learned how to use our calculators the other day. Everybody had a different one, so everybody's kind of, the buttons would go in a different order than others. So however you remembered how to do this, but in mine, I would put in 24 and hit tan, and I get 0.445. So I'm going to round that to 0.45. That's tan 24 equals y over 9.5. Solve this using the algebra skills that I have. And y is going to equal that 0.45 times 9.5, 9.5, whoops, 9.5. You can plug it in your calculator and see what you come up with, times 0.45, and you end up with 4.275. So we're going to round that to the nearest second decimal place. 4.28 is the side length for y. Now let's solve for, let's do a third step here. I don't want to lose sight of my little triangle over here, so I'm going to do this over here if you don't mind. You're just watching me anyway. So for the third part of this, we need to solve for h. So what is the measurement for h? Okay, so we're going to use the 24 as our angle again. We notice that h this time is here. It is the hypotenuse, so our whatever trig ratio we choose to use has to include the hypotenuse. So let's go back up here and look. We have there's the hypotenuse, ka, there's the hypotenuse, toa. But toa doesn't have the hypotenuse as part of its ratio, so it's going to be one of these two. Well, which one is it going to be? Well, we need the hypotenuse, and if we use the opposite side, that would be okay because now we know what y is equal to, so we go opposite 24. We could use that since we know y is 4.28, or we could use its adjacent side of 9.5. And I suggest you use that, and I'll tell you why, because when we found 4.28, and by the way, those should be little squiggly lines over there. That was an approximate measure. But 9.5 was given as an exact measurement. So let's use the hypotenuse and the adjacent. So we're going to use cosine right here. So we're going to use cosine 24 degrees equals We have adjacent over hypotenuse. The adjacent is 9.5 and the hypotenuse is capital letter H. So we're going to do the same thing we did a moment ago. We're going to solve for H. So let's find cosine 24. That's the first thing we want to do. So take your calculators, just see if you come up with the same thing I do. So I would put in there 24 and hit cosine. I get 0.913. So we're going to round that to 0.91. We'll leave it there. Equals 9.5 over H. And then we just do our math here. We're going to, let's see how 9.5 over H. How do I have H here? 0.91. Okay, well, I was just looking at something really quickly here. So the hypotenuse should end up being 9.5 divided by 0.91, and you end up with 10.439. So it's going to round itself to 10.44. Okay, but that just kind of shows you, I wanted to do an example just so that you could watch, so you could see how I determine which trig function I want to use. So now we'll build one in your notes. So let's take a look at this one here. So we have this triangle. We have 52 degrees. I need to put in that corner over there. And if you would, on yours, let's go ahead and name those two sides that don't have anything on them. We have one side that is 12. We're going to name the hypotenuse, and keep in mind the hypotenuse is always opposite the right angle, so the hypotenuse is what this triangle is actually laying on. We're going to call that little b, since its angle opposite there is big B. And on the other side, its opposite angle is capital letter A, so we'll call this one little a. Okay, so now we have this thing labeled up and we have parts that we can use. Let me grab my blue pencil here. All right, so the first thing we want to do, we have to figure out any missing parts, and what they really want to know is what is the measure of angle A, side A, and side B. So that's what we're going to be looking for. So let's start with angle A, because that really is the easiest one to do, simply because I have an angle measurement, I'm going to highlight it, of 52, and I know that I have an angle measurement of 90 because my right angle is 90. So if I just put together, remember the sum is 180. You can do this really quickly probably. We just add these two together, subtract it from 180, and you end up with 38. So the measure of angle A is 38 degrees. That's the first one. Very easy. And I'll go ahead and plunk that in here in blue. We're not actually going to use it. We could, because remember, our trig ratios are set according to an angle and only an angle. So when we're looking for a sine, cosine, or tangent, it involves an angles measurement. But we'll stick with using 52 for this example. So now let's go ahead and look for A. So number 2, we're going to find A. Okay, so let's look at this. So I have to figure out, here's A. According to my angle of 52, I don't know whether I should use sine, cosine, or tangent. Well, let's think about that. So we have SOHCAHTOA, right? SOHCAHTOA. And if I'm looking for A, where it sits according to that 52-degree angle, it looks like it's an adjacent side. So whichever one of these three I choose has to at least have an adjacent side in the ratio. So sine does not. But cosine and tangent do. So let's see, what are we going to use? Well, I don't want to use this B because I don't need two variables. I want to pick a side that already has a measurement on it. Well, this one does, 12. So we'll use adjacent and the hypotenuse, or excuse me, adjacent and opposite. This is the opposite side from the angle. So we need to find the trig ratio that has adjacent and opposite in it. Adjacent and opposite looks like it is tangent. So for A, we're going to use tan 52. And we know that that is, I'm going to write right underneath it, it's adjacent, excuse me, opposite over adjacent. Okay, so then we'll just fill in our parts over here. So opposite over adjacent, it's going to be 12 over A. I'm actually going to move that slightly. I'm going to just put opposite over adjacent right out here so we know that's what tan is. Okay, so we have 12 over A. So now we just go ahead and we solve for this. So let's find the tan of 52. Tan 52, put it in your calculator. Let's see what you come up with. Put in 52, hit tangent. And you should get 1.2799 and so on. We're going to round that to the nearest second decimal place, so we're going to raise it up to 1.28. That's what tan 52 is. 1.28 equals 12 over A. So let's just do our math here now. And actually, you can do cross products here even. So let's do 1.28A equals 12 and divide by 1.28. Put that in your calculator and you should get, let me put it in there because I think I had to round it. So we do 12 and we divide it by 1.28 equals 9.375. So we'll raise that up to 9.38, and that is the measurement of side A. Now let's find B. I'll go over here and do, I'm going to put it way over here just to give myself some room. 3. Okay, and in green, I'm going to write SOHCAHTOA because we're going to have to evaluate again which ones we're going to use. SOHCAHTOA. All right, so let's take a look here. So we're going to solve for B now. Find B. Okay, so to find B, let's locate that on our diagram here. B is right here. And it looks like it's on the hypotenuse, right? B is at the hypotenuse. So we know that whichever trig function we use has to have the hypotenuse in it. Well, tangent does not, so we can scratch that one off. What is the other side we want to use? What side is given? Well, we know 12, and 12 was the opposite. So which one of these trig functions has opposite in it? Right here, sine does. So we won't use cosine. We're going to go ahead and use sine. So let's find sine 52 equals, and what is this? It's opposite over hypotenuse. So opposite is 12, hypotenuse is B. Let's find sine 52. Plug in 52, hit sine. You should get 0.78, so 0.79. We could do cross products again here. It's probably the easiest way to do this. 0.79b equals 12. We'll divide by 0.79. And b is going to equal, let me put that in, 12 divided by 0.79 is 15 point, oops, wait a minute, something didn't turn out right. Let me go back a minute. I'm off just a smidgen, and I think it's because of the way I put sine 52 in. So hold on just a moment. We're actually going to watch what I'm going to do here. Sometimes, and I noticed as I went through this lesson that sometimes it works out if you do it the way we did over here where we calculated for tan 52 and used 1.28. But I noticed I was like just a bit off on my decimal when I did it that way on the other problems. So here's what I'm going to suggest we do. I'm going to leave sine 52 as sine 52 until we get to a point where we're going to calculate it. And I'm going to show you what I mean by that. So let's see here. Let's do sine 52b equals 12. Divide by sine 52. Right? Do 12, and you could try this both ways, and you're going to see you're going to get a slightly different answer. But if I keep this all as one function or one calculation in my calculator, it really gives me closer to the more accurate answer. So let's do 12 and divide it by put in 52 and hit sign and then hit equals. You're going to get 15.228. And we're going to round that to 15.23. So B is equal to 0.1523. Okay, when I didn't do that, I think I came up with 15 point, just under that, like 15.18 or something like that. All right, so let's try another one. I want to not use the same example here, but I would like for us now to look at how do I solve something when it's looking for an inverse situation. So I'm going to go grab one more sheet of paper here. So for example, let's say we have this, and you can just watch on here and then we'll put one in your notes because there is going to be one in your practice set. All right, so you're going to have this triangle. It's a right triangle. And we have a side that's 7. We have an angle that's A. We have a side that's 6. We have a measurement of another angle that's B. We don't know it. And that is all we have. The side over here is X. Okay, so we're needing to figure out here all the missing parts of this. So we had to figure out angle A and B and side X. Okay, so golly, you look at this and go, well, I don't know how to use the trig function for this because I don't have an angles measurement. I can't say that they're both 45 because nothing indicates that this is an isosceles right triangle, right? So I don't know that the sides are equal, making my base angles equal, so I can't use that. So I need to figure out something else. So when you have a missing side, we can use the Pythagorean theorem. And remember what that is? That is simply a squared plus b squared equals c squared, where each one of these is a leg, and the c is the hypotenuse. So let's fill in our parts here. So we would have, we'll take the first leg, we'll use it as x squared plus 6 squared equals the hypotenuse squared, which is 7 squared. And if you just keep solving this, go ahead and watch what I do here. I'm just going to use algebra to work through this to come up with our answer. I would have x squared equals 13. You have to take the square root, right, to get rid of that square in my x. And the answer is just simply the square root of 13. So x is the square root of 13. So we successfully found a side measurement. Now to find angle A, we have to think about our trig functions again. Okay, now I do have a couple of sides, right? I have the hypotenuse and I have an adjacent side to A. So let's think about what we need to use. Are we going to use sine? Let me write SOHCAHTOA again, because that's really the easiest way to see it. So, let me put a number here, just so you can follow me. SOHCAHTOA. All right, so what do I have here? Here's A. I have a 7 and a 6 I could use. That square root of 13 is going to create a nightmare, so we're not even going to try to use that one. But let's focus on the measurements that were given, the 6 for one of the sides and the 7 for the hypotenuse. So if you need to label this in case you're not sure which sides are which, for letter A, 6 is going to be your adjacent side. 7 is always the hypotenuse, always, no matter which angle you're looking at, because it is across from the right angle in your triangle. All right, so we need hypotenuse and adjacent. So which one of our functions down here offer both of those? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Looks like it's going to be that one. Tangent is opposite over adjacent. So it looks like we're going to use cosine. So let's use cosine to find the angle. But remember, it's going to be a little bit more difficult because I don't know what to plug in for angle A. So this is one of those things where we're going to have to use the reverse to figure this out. So let's write down what we're trying to find. So keep in mind, it's going to be sine of the angle, right? We just don't have a measurement to put in there. Equals, we're using adjacent over hypotenuse. So adjacent over hypotenuse is 6 over 7. So if I divide 6 divided by 7, 6 divided by 7, I should get 0.8571. I'm going to write all that down, 0.8571. I'm not going to round that, okay? Now, what does this 0.8571 mean? 0.8571, okay, the angle A that we're talking about, the angle A whose cosine is 0.8571 is the inverse cosine of 0.8571. So this is where we're going to use the inverse key. So I'm going to take 0.8571 and find the inverse key for, I wrote sine. I wonder if you guys are screaming at me right about now. You're probably sitting there going, Mrs. Quigley, please catch what you did. We need cosine over here. All right, so 0.8571, and I'm going to, remember I have to hit my, make sure the degree key is what's on, and I have to hit second on mine, and that will give me, that'll reveal like the inverse of sine, cosine, and tan, where you see the -1 as the exponent on your calculator. So I'm going to hit cosine -1, and I'm going to get 31.007. So I'm just going to say that cosine, that A is actually equal to, this is what I wanted to erase right here. Okay, so what did I do? Let me just write here. So in the calculator, you put 0.8571 and you hit, I had to hit my second key, and it'll give me cosine -1. And when I get that, I end up with 31. So the angle A's measurement is 31 degrees. Okay, now we have to find angle B. Okay, so we're going to look for B. So an angle B, now this makes it kind of easy. What did I say angle 1 was? 31? Yay, let's make this easy. So now I know 31 and 90 is 121. Remember, the sum of the angles in that triangle have to total 180. So 180 minus 121 is 59 degrees. So angle B is 59 degrees. Okay, and that's how you figure this out. So I'm going to let you guys work on the practice problems because the lesson's getting a little long. And if you have questions on how to do this, I will be happy to work this out with you in class. Okay, guys, thanks for watching.